good afternoon and welcome to my final year presentation. My name is Errina and I'm under Dr. Alex. So what is my agenda for today? So what is the problem that I'm facing in this? What is the problem that I am trying to fix in this project? First of all, is that the existing IEMS, which is an Intelligent Energy Management System, is vulnerable to external changes in the server because it is based on an external server. So what I'm trying to fix now is to create an enhanced IEMS for an optimized solar PV system. So what exactly is IEMS and solar PV system? Solar PV stands for solar photovoltaic, and it harnesses sunlight to produce energy. As you can see here are the solar panels at block 39. So the energy collected is in DC and will be converted into usable AC using inverters. So this IEMS, Intelligent Energy Management System, is a system that stores and monitors data from this solar PV system. It enables real-time visualization and deeper analysis on the data collected. So this is a system overview. So the energy collected by these solar panels will be converted into AC as I mentioned by these inverters. Afterwards, it is stored inside energy storage system, which is ESS, and the data will be logged by Smart Logger 3000, which is a data logger. Afterwards, the data is processed under programming software and written into a database. The data collected from this software is also presented on the dashboard. So when the program runs, two different things will happen. On the data logger side, it will read and collect data and it will display on the dashboard. It will scale accordingly as well. And on the database side, we will create a table if there is not already an existing table. And it will collect the data from the data logger after it is scaled and write into the database. So what are the main objectives of this project is to design and program an enhanced IEMS and to integrate this solar PV system with the IEMS. Afterwards, we can conduct analysis on the data collected. Some of the key parameters that I'll be measuring here will be the system input and output, energy and power. And for the inverters, it will be the same thing, input and output power, energy, and also the phase currents and power factor. So the first step to achieving these objectives is research and understanding. So I have to learn how to use the softwares and also understand the key concepts behind the solar PV systems and the inverters. Afterwards, I do a simple prototype on the smaller scale and it will then be integrated with the solar PV system. Then testing will be done and troubleshoot any of the issues that happen during the program, and also we'll be adding new features to this IEMS. Afterwards, we can conduct data analysis by taking the data collected and calculate the efficiency of the overall system and the inverters. Some of the methods that I'll be using is LabVIEW, SQLite Studio, and Modbus TCP. So first of all, LabVIEW will be the main software that we use as the interface because it's very user-friendly and is able to connect between different types of softwares and devices. Next, our database will be using SQLite Studio. It's a relational database and it manages to collect the data and organize it into neat tables. And lastly, we have Modbus TCP. It will be the physical connection between the data logger and the computer. So it's able to accurately interpret data, which is why I'll be using Modbus TCP. So this is the main program. This is the dashboard, and that is the block diagram, the behind the scenes of what is going on here. So as a mechanical engineering student, it took me quite some time to get to that stage. So what are the key features of this enhanced IEMS? First of all, it allows for real-time data logging and analysis, organized data collection, automated scaling process, and it's also very easy to access this data collected. And last but not least, error management and system tracking. So how does this make it different from the initial IEMS? So initially, as I mentioned, it was based on an external server. However, this current database that we're using is localized, which means that all the data that is collected is stored inside the computer files. making it easy to access even after it's being displayed on the dashboard. So next, some of the challenges that I faced was in the initial attempt, I used a different database and I was unfamiliar with how to use the different softwares and the key concepts. So it required me more time to build up to the final stage. And also, since the initial database was unable to connect to the program software that I was using, I had to change the database. During the testing, I had some challenges like unstable TCP connection. So the physical connection was exposed to the outside conditions like rain and wet weather. So it was sometimes there would be shutdowns, and there was also occasional Wi-Fi shutdown, so I couldn't really collect the data at times. So the database was also constantly locked during the troubleshooting process because I had to force the program to stop as there were some issues with it. So this is the data analysis that I have done on the overall system and also the inverters. So I've taken in the instantaneous efficiency, which takes in the real-time data collected using that formula. So as compared to the inverter instantaneous efficiency, the system efficiency looks over the whole system, which means it looks at the solar panels as well as the inverters. While the inverter instantaneous efficiency only looks at how capable these inverters are able to convert from DC to AC. I'll also be looking at the specific yield, which is the total amount of energy collected per kilowatt peak. So it typically ranges about 1,000 to 2,000 kilowatt hour per kilowatt peak. So here I've done a comparison between both of the inverters and both inverters with the rated efficiency. So as you can see here, comparing inverter performance, I found out that even though inverter 1 was able to produce more active power, which is the usable AC power, its efficiency was slightly lower than inverter 2, which is less than 1%. Which means that inverter 1 was able to take in more DC power than the inverter 2, but was unable to convert as much of it. And when compared to the rated efficiency, it was slightly lower, which is expected due to real-world conditions and other factors like conversion loss. Moving on to the system instantaneous efficiency, it was roughly about 97 to 98% on average during the peak hours, which means that during 10 a.m. to 1 or 2 p.m. And the specific yield that I calculated based on the data collected on the 11th of February was about 1,436 kilowatt hours per kilowatt peak, which means it's about the typical range that it should be. So what is the environmental impact of this solar PV system? So I've calculated the total CO2 emissions and also the total trees saved by using solar panels. So based on the data collected on the 11th of February as well, we've avoided at least 119,000 tons of carbon dioxide, which is equivalent to about 619 trees. So in conclusion, this system manages to reduce the global greenhouse gas emissions and which in turn reduces the climate change. So in conclusion, what have I learned was that I managed to expand my knowledge on not only data analysis and renewable energy, but I also managed to pick a bit more into the electrical side of engineering. And the impact of this IEMS on society was that with deeper analysis done on these solar panels, we are able to optimize its efficiency, which in turn reduces the reliance on non-renewable energy. And lastly, future improvements that I think could be made to this IEMS is a query system that will be able to extract a specific data required, as well as enhance data analysis, as I mentioned, to optimize the use of solar PV systems, and also to upgrade this database to a cloud base. So instead of only one person can access the program, the database, more than one person, so it will be at least a developer side and a user side. So in the future, when it's upgraded to a cloud-based database, it can be commercialized or even shared to other people. So this is just a short video of how the general tech works. So this overlooks the whole solar PV system. It looks at the input and output, as you can see, and it compares the DC power. inverters, so inverter 1 and inverter 2, as you can see it logs and you can see the values here. This is the system efficiency, so it overlooks the whole system as well as the environmental impact, as I mentioned. This is what happens when I use the error management system. It drops down to 0 and then it goes back up. So which means that after I press the simulate error button, we can test out that even though the connection has been cut off, it will automatically reconnect and continuously log data. So we can backtrack this to the database table. As you can see here, there's quite a lot of rows that are collected and there's no limit to the number of rows that I can save in this database. So just now I showed you there was 0, which means this was the time where it was the error. And I'm showing you here is how many times it logs data in 1 minute. So it's about 8 times, which means the data comes in about 8 seconds each time. This is the main overview of the log diagram. So you can see what's happening here is after it's connected for configuration, it sends the data to the different action engines, which is actually a smaller, more programs, but simplified. And then it was saved to this dashboard. The dashboard program is on the outside because there's a lot of output. This is one of the action engines to read the data loggers. So as you can see, previously it was a red color case, which was when there was an error. So it will run the error case, and when the error is solved, it will run this case. This case means that it will just collect the data and based on the address that I've filled in. This is the error logging file. So it tells you when the error happens and when what kind of error is going on. So it changed quite a bit. So when you first start the program, it will run an initialize stage. And then afterwards, it will run the log case. So during the log case, if there are no errors happening, nothing will be saved inside the error logging file. However, if there is an error, then it will state down the error code and the error source. So you can tell when and where this error is happening. So this is actually our scaling. So after the data logger extracts the data, it goes through this scaling process. It's based on the data type and the quantity. And this is the gain that will be divided by at the end. This is on the database side. When you first start the program, it looks at whether the table that you want to insert is already existing. So it's quite small here, but you can see this, the table name is DLFIN. So final data logger. And if this table is not existed in the database, it will run an error case and it will create the table before using this whole insert statement again. But if the table already exists, it will just run normally and then go to this non-error case. And lastly, this is the efficiency calculator for the instantaneous efficiency. It just takes in the input and output and does the formula accordingly. That's all I have. Thank you.
Next time you better put some slide numbers because it's very hard for me to tell you. Go through the slide with the efficiency equation. Definition of efficiency. Right, we normally don't write equation all in one line, alright? So I assume that it is a subscript
Yeah.
that is missing. Why is it that you don't subscript it, your AC and your DC?
So usually P would means power, and as I mentioned, I use AC is an output and DC is an input.
So your efficiency is the ratio of your output over the input, so it's your AC output over your DC input. So it's just only the efficiency of the converter
Yes, the converter.
itself. Do you ever measure the energy loss, okay, through storage?
So there's a few parameters that I am unable to like measure because from what I have, the data logger only has this few measurements. So
does your data logger log the charging currents going into the batteries?
no, because the batteries are actually newly arrived, so I haven't yet managed to integrate it into this system.
So yeah, just
For now,
measuring the
yeah.
efficiency of the converters
Yeah.
itself. What is the key thing that you learn, alright, about the efficiency of these converters?
So I learned that it's actually quite high compared to what I actually thought of, and that this efficiency takes into depends on what you're looking
We
at.
look at your last slide, where you actually have the calculation based on the last slide, where the diagram is not this is not the last slide, yeah. Because again, you show the picture of the efficiency. Yes. Your division, there is a 0.98 in it, alright. Why is it there's a 0.98 inside your division?
Oh, because for this calculation that I'm taking, it's actually taking it from the active power. So when you divide by the AC over DC, this is the value that you get before I scale up to 100%. Before I times 100 to get the actual percentage. So then after I times 100, then it gets this value. This is because there's some accuracy changes in this program and this because of the data type.
Mr. Lu, that's in real time, you know.
I know. I know. But is the result of the AC. Then after that, sorry. So what happened is that you multiply by 100
Yeah.
to scale it up.
Yeah.
Then get the
Then it gets
the real time efficiency of the
yeah.
conversion. Okay. Now the other thing about the diagrams I don't like is that you just give too much to the menu. You don't want the menu like the diagram before this, okay? You want to look at the actual diagram, you end up being too small. You can actually zoom in 50% and then cut out all the extra file, edit, view. We don't want all those on the side, okay? We want to see what's in the center. And end up the center cannot be seen. It's really small. So this is not the worst one. The earlier ones that are even worse, okay? Unreadable, okay? The numbers are unreadable. The system lag. Maybe this one also the other thing is you have all these. This is necessary to stack them all in one vertical bar. Can they be put into an array of say? I don't know how big are your how tall are your columns? 10 or 20?
There's about 21.
About 21. So
yeah.
can it be rearranged in 2 by 10 or 5 by 4 so that you just know all the data? So you know that it's a ladder sequence. And the snake is way in. You know how the snake goes? Right. Rather than stack them all vertically, in the end you end up taking up so much vertical space. Otherwise you can zoom in another say 54% at least. Is it possible?
Not really, because this one it goes by matching.
I know. So what happens if you have got this column to be 400, then in the end the whole thing will be just all the column height. Some more your view is broad, not tall. So you have all these tall columns, alright. I don't know about the graphical user interface. Is it possible to reconfigure?
It's not possible. This is the only way that I can do it. So if I were to do it 2 by 2.
And this one is a video or?
It's the video, but it's
But
spread
in
out.
most of the time I see the video is static at the end. The beginning was a little bit of movement, you know.
It's a very short video.
Yeah, very short one, about half a second, I think that's all, you know.
Yeah, because if you
So you can tell us what was all the changes in the half second, is it? Then after that it becomes static for the rest of the video.
No, the video. So if I were to play it like normal speed, it'll be very slow because it's on the highlight function, so it like slowly shows you what's going on, and then you will have to slowly take in one by one, so it will end up being like about 1 or 2 minutes.
So each one is supposed to be what, 1 or 2 seconds or?
Yeah, it's
so
usually very fast, but just to show you how it works.
To go through all the numbers, feed them one at a time. I know this is some kind of a video, but most of the time it's concentrated on a very small time scale. The first few seconds, after that it's static throughout. So I don't know what's the objective. You know what I mean when you play the video, it's just the first half second of something happening, then after that it becomes static throughout. Let's do an example. We play say we play this slide, okay? Let's see how it goes up. Just go to that slide and play that slide. Yeah. There's something happening. Then after it propagate. After that it propagate through the end up result. So it's the first few seconds. Then after that it stays there static. So what are you trying to show really?
I'm just trying to show you like what happens at the start and how it goes through.
If it's what has happened at the start, then you will have to freeze the start for a certain amount of time for us to absorb. By the time you try to absorb the start over already, and then now it's the end. So I don't know what you're trying to really to show. You be careful of what you're trying to show, and whether can it be seen.
Yeah.
Like for instance, seated from here, many of the numbers cannot be read, or many of the titles of the names cannot be read. So what's the purpose here? You must get the purpose in what you're doing. Alright. So overall, what is your take about efficiency here?
I think efficiency is very important to calculate, especially in this kind of systems where you have input and output. So using this efficiency, you can really see what parts is not working, what parts is working. For example, when I calculate the inverter efficiency and this overall system. So if I were to say that the overall system is lower than or is higher than the inverter efficiency, then that means there might be something wrong with the inverters. And also when you're comparing it to the rated efficiency like I did with the inverters, you can see whether it's too far off or it's too is in an acceptable range.
I thought the inverters contribute to the overall system efficiency.
Yeah. So if the overall system efficiency is like really low, which means that it might be the inverter's problem, or it might be the solar panels which is like require maintenance.
Yeah, when you multiply 90% efficient, then after the next one is again 90%, the overall becomes how many? If the first stage is 90% efficient, second stage is again 90% efficient, then what is the overall efficient if there is only two-stage system? Your stage 1 is 90%.
Yes.
The stage 1 feed into stage 2 doesn't go anywhere. Stage 2 is also 90%. Then what is the overall system efficiency for stage 1 and 2?
90%.
Actually, the inverters are independent.
The independent. The inverters don't feed the power somewhere else.
They are independent. Two independent inverters feed to the grid.
It's comparative, but how about states? If the inverters feed to other stages, like for instance, your inverters feed to other things that are also 90% efficient, then overall the system efficiency by the time the consumer use it, what would be the overall efficiency? Then I repeat that. You've got a system that has got two stages. Stage 1 is 90% efficient. Stage 1 feed into stage 2, also 90% efficient. Overall the system, alright, what would be the system efficiency?
About 80 to 90%.
Huh?
80 to 90%.
How much? 80 or 90?
80.
80, yeah. It's about, yeah, it's about 81 actually. Okay, not so. Okay. So you know the impact if the further down system is almost as efficient as your inverter, you tend to say if both is 97, have good news lah. Alright, if both is also 90, then it's bad news. Overall, the whole system is is only 81% efficient. Alright, that's why you want to keep the efficiency high, because further down the system may not be so good. You lost energy. What's the impact of low efficiency of your inverters in the practical sense? What's the result of low efficiency of the inverters?
The input power won't be as properly utilized because you cannot.
Yeah, that one okay. But the outcome, what is the end result?
The overall.
What happens to the inverters itself?
It might overheat because there's too much.
I see. Because the energy loss is through heat. Okay,
Yeah.
the heat comes out.
I just want to give you a chance to maybe another 3 more minutes. Anyone else have a question? Dr. Lee or Mika? Alex? Any questions? Maybe I ask one question, okay? A quick one, so Errina, what was I going to say? Actually, I have no question. I just have a comment. Good job on submitting your report on time. 11:59 is on time. But please, I allow multiple outlets. So please change the title from interim to final.
Oh, okay.
Yeah, okay. Any last questions? Quick one, maybe? No?
Errina, maybe one quick one. For future work, can you elaborate a little bit? What do you think? The student who is going to take over this project, right? What do you think are the suggestions? The query part, yeah. Can you mention a bit?
So in the future, perhaps you can use Python so that you can also access it from other devices. Also, the cloud-based one will help with the Python because right now, because it's localized, it's a bit difficult for Python to reach into the database. So in the future, maybe if there's someone who has a background in Python, then it will be better to form this query system also.
Using Python.
Using Python.
Okay. Something for future work. We'll continue the project.
Okay, thank you, Errina.
Yeah, thanks so much.
Thank you.
Thank you. Yeah, okay, thanks. Thank you. Thank you.
We have 2 minutes to set up.